Hi guys, so here we're going to talk about molarity. You've heard me talk about molarity before when I've given you like a solution of, for example, 0.1 molar HCl. That 0.1 molar means the concentration of hydrochloric acid. You've seen this, you've also had 1.0 molar HCl. So in molarity, you actually end up, you have more particles of the solute, whatever you have, for the higher concentration or the higher number of molarity. So here you'll need your notes, your calculator, and the mole map. So let's take a look at the mole map here. We've already dealt with liters of a gas at STP in Unit 3. Grams of a solid in molar mass was pretty much the last few videos. And so what we're dealing with here is liters of a solution to moles. Those things right there. So we know we're going to have M. Or capital M here means molarity. It also means moles per liter. So here are some terms we just need to make sure we look at. Solute, that's the element or the compound that we're dissolving into the solvent. The solvent's usually water. It's a universal solvent because it's polar. So don't forget, water is polar, hence why it's called the universal solvent. When it's polar, it can dissolve all those particles in there. We can measure concentration and molarity. We can also measure in parts per million or parts per billion. We use parts per million and parts per billion, especially when we're dealing with contaminants in the environment. You know, how many parts per million have been leaked out into a river? How many parts per million of contaminants have been leaked out into a river? Here in chemistry, we'll focus in mostly on molarity. You can find the formulas for molarity using Table T. So here, this is just from Table T, the back side of your paper and of your reference table, and it's right here. Molarity is the moles of the solute per liter. So you can have capital M or moles per liter. If you need to know what parts per million was in case it was there, here it's the mass of the solute over the mass of the solution. So taking, for example, if we had NaCl, the mass of just the solid NaCl divided by the mass of the NaCl in water, and timesing that by 1,000,000. We also have the mole calculations down here just to kind of remind you. The number of moles is the mass over the gram formula mass or the molar mass that you take from the periodic table. So here we need to rearrange some equations. We know that we have moles here and moles here. So we have to make sure we can put all of these things together. When we rearrange the equation, the molarity, and I'm just going to use capital M because that's what we normally use in chemistry, is the moles of the solute, but I know moles of the solute is actually this whole thing. So it's the mass, and sometimes this is what you have to find out. This is actually what I have to find out a lot during lab, or when I'm prepping a lab for you, over the gram formula mass or the molar mass, over the liters of solution. So don't let me trick you. I might give you milliliters. Make sure that you convert it over to liters by multiplying by 1,000. Right, so this is generally what we use when we're trying to figure out molarity if they haven't already given us moles. So if they're giving us grams, this is what we'll use, this rearranged equation. If they're giving us moles, we'll use that. Alright, so the first example, what is the molarity of a solution in which 54.7 grams of a solid NaCl are dissolved in 1 liter of a solution? So we know that we're given grams here, we're not given moles, so we have to use our rearranged equation. So our rearranged equation is molarity, or moles per liter, is equal to the given mass over the gram formula mass, which is that molar mass from the periodic table, over the amount of liters. So let's fill these in. The given mass here is 54.7 grams. The gram formula mass, that's again what you have to take from the periodic table. We have NaCl here, and when I add up the Na and the Cl, I get 58.44277 grams per mole. Since I have grams per mole here, I can actually move that mole up there. And that's all over, in this case, 1 liter. And I've used liter, and that's okay. So you'll punch this into the calculator, 54.7 divided by 58.44277 divided by 1, or just leave it as itself, because anything divided by 1 is itself. And the calculator gives me 0.934 0.59, etc. Alright, so now we have to look at the number of significant figures. This has 3 sig figs, this has 2, and my molar mass has way more than 3 or 2, so we're just going to focus on the 2 that are given here. Since the liters gives us the least number of sig figs, that's as accurate or precise as we can make our final calculation, so we move 1, 2 units over because that leading 0 is not significant. I'll draw a line there, we'll see what that 5 does. So it's 0.94. Now let's take a look at units. We have grams cancel, and we end up with moles over liter, and that's what we have here. Molarity is also moles over liter. So we wanted that molarity. You can give me 0.94 big M or 0.94 moles per liter. As long as you box the answer, you're good to go. Alright, number 2. What's the molarity solution in which 10.0 grams of solid MgClO3 is dissolved in 500 mils of a solution? We'll go back to the rearranged equation that we have. I'll make this into moles per liter, just to show you it's the same thing. That's the given mass over the gram formula mass over the liters. The given mass in the problem was 10.0 grams. The gram formula mass, I just need to make sure I add up the Mg, the 2 Cls, and the 6 oxygens. When I do that, I get 191.2074. If you get something differently than I do, make sure that you let me know during class. And let's see. When we have, that's going to be grams, mole, and that's going to be over liters. But hey, look here, I gave you milliliters, so convert that over to liters. That ends up being 0.500 liters. So I've taken that 500 milliliters, divided it by 1,000 to get to 0.500 liters. Let's check our units, cancel out the grams. I'm left with moles per liter. So we have 0.104598, etc. So let's look at the number of sig figs. There's 3 here, 3 there. There's way more than 3 there, so I know that my least number of sig figs is 3. 1, 2, 3. So that's 0.10, and that 5 rounds up that 4 to a 5. Molarity, or moles per liter. Right, now number 3, how many grams of solid sodium chloride should be used to prepare 2.0 liters of 0.500 molar solution? This is the calculation that I do all the time. So when I'm prepping a lab for you, I know that there's going to be 6 groups or 12 groups times however many classes I have. And I know I need to have a certain number of milliliters per group. And the directions, or the lab itself, needs a certain molarity. So when I'm making this, I'm taking that sodium chloride, putting it onto a scale, taking that solid sodium chloride, putting it onto a scale, and then adding it to a volumetric flask and filling it up with water to 2 liters. So this is the calculation that I do quite often. So let's take our regular old formula that we had before. I'm going to use moles per liter is equal to the given over the gram formula mass over the liter. Alright, so now I need to rearrange the equation. I need to know what that given is. So I need to move and rearrange the equation. When I do that, I have moles per liter times the liter times the gram formula mass, which is also in which is grams per mole. So we'll do that calculation in just a bit. So that's the given. Alright, so my given is my unknown. I know I have 0.500 molar solution, which is my molarity, moles per liter. I can write it out as moles per liter just to make sure my units cancel. I know I need 2.00 liters. And this is sodium chloride, so I will use the molar mass, or the gram formula mass, which is 58.44277, and that's grams per mole. And that's all to give me that given. or the number of grams needed. So let's see if we can cancel out some units. We have moles here and here, liters there and there. We're left finally with grams, which is the unit that we want at the end. So I punch this into the calculator. I have 58.4427, etc. So I know I have 3 sig figs here, 3 sig figs there, so I go 1, 2, 3, and that ends up being 58.4 grams of NaCl. So when I'm prepping this, I take 58.4 grams of solid sodium chloride, take the mass of it using my scale, put that into a large 2-liter volumetric flask, and add water to it until it comes up to the 2-liter mark. And then mix like crazy. Alright, to summarize, molarity is just a unit of concentration. It's moles per liter, and use the formulas to help you out. If you need anything, just let me know. If you have any questions, let me know during class. Take care. Bye.